So our next presentation is from our second sponsor today, E4, Giordano Mancini. Thank you very much for your sponsorship.
Thank you for having me in this beautiful venue. Really impressive how these events has evolved. And so I'll give you some updates about my company, what we do, and what we see as it may happen in this time of great disruption in the HPC world. So a brief of history. E4 is a system integrator. We started in 2002. We are a very hardware-focused company. We do a lot of in operations, deployment of clusters and rack stack and these kind of things. But over time, we evolved a lot, and now I would say that we are a company that can provide end-to-end solution, turnkey, that can be made operative from day one. And as a company, we also invest a lot of resources, a lot of time in European projects. We can make some examples. For instance, our participation in the MAX Center of Excellence project about molecular physics, or the RISC-V for Astro project. Usually in these kind of actions, we act as a co-design, or we do benchmark, and this gives us a lot of, I would say, awareness of how HPC is changing and what the market is asking for. And we also have some very relevant milestones, I would say. For instance, we were the first to deploy a RISC-V based cluster called Montecimone before 2020 that was entirely made up for HPC. And these are some of our latest milestones. For instance, we deployed Marco Polo. It's what wasn't a tender won by us. We were acting as partners. And in this action, with Lenovo and Vastata, we did the complete installation up to the benchmark, both synthetic and application benchmarks that were critical for the acceptance of the machine. Marco Polo, as we'll see, is located in Tecnopolo. Tecnopolo is one of the biggest sites in Europe, I would say, for HPC, because it hosts Cinega and also the CMWF weather facility. And in this place, we do 24/7 maintenance on the system. And for instance, ECMWF went from having a lot of problems when it was deployed initially to having now less than 1% of nodes out of service in these days. We also, this is another milestone. Gaia is the largest cloud for public research in Italy. It was the first multi-million tender that we ran in Prime, and we won together with Dell and Vastata once again. And it is a project based completely on OpenStack because it's meant for interactive workloads. And that is that. Based on this experience, we participated in 2 tenders of the EuroGU AI factories. We are waiting for the results, and so finger crossed. And this is the basic philosophy of our company. Basically, we have labs in which we run extensive tests on the hardware, both before deployment and to validate new solutions to test out new integration. This is how, for instance, systems like Montecimone or Davide were built. And over time, to make this pipeline ever more fluid and efficient, we developed a number of tools inside, gluing up open source tools that make possible to programmatically access all the information about how a cluster we would like in the future, what is the state of a machine from the moment that that machine is created in the company database and maybe is not even right now in our prem. And in this way, we create at each step single source of truth points from which the test of a machine can be done. And this, of course, over time creates a big knowledge base about what are the features of the given hardware platform, what are its strength points and these weak points. And of course, we got the purpose and the ambition to provide end-to-end solutions. So it's not only hardware, it's also software platforms. It seems that following the OpenChami talk that we are not the only one who like Greek letters, Greek mythology. It's all very well in any case. We have basically an infrastructure layer solution that can deploy basically a cluster before giving its personality to nodes as HPC nodes or Kubernetes worker nodes. And on top of that, we have verticals that allow us to dedicate a cluster to a given purpose with automation glue. And we also do research and development in quantum. On this, I just want to cite my colleagues that will give the speech, Gabriele and Roberto, on Thursday. So be sure to attend this one as well if you can. And so this is a basic example, a small one about our, right now, an infrastructure deployed by us would look like. It's the bottom layer, Atlas, basically is based on OpenStack, and it contains other glue that we created. And so this allows us to provide both all the basic services from HPC or to enroll and give nodes personality in different ways, and it's very flexible. And on this, we integrate different kind of storages, both open like BGFS or enterprise grade like VAST, with which we have a very strong collaboration, or in this case, Linstore that was used to provide space to the hypervisors, to the virtual machines hosted by the hypervisors in the cluster. And this architecture basically allows you to create a sort of hub-spoke architecture in which you can give a tenant privileges that allows them to see their machines as another cluster, a cluster within a cluster. And this is possible, of course, in other ways, as we have seen. I will not elaborate a lot about our choice of OpenStack. Of course, today we have listened a lot about OpenChami, and yesterday, by the way, I did a tutorial which I found very, very interesting and took a lot of inspiration. I would just say that the reasons are very similar. So when we started using OpenStack some years ago, we wanted something that could give performance and allows us to control the hardware in a programmatic way. We wanted to be able to integrate different kind of necessities, so both, say, batch scheduling based HPC or Kubernetes workloads, and more important than everything else, to have a strong community behind our choice to be sure that we could be consistent in all the years. So as a system integrator, of course, we will see what happens in the HPC community, which is kind of different from the OpenStack and Open Infra community. We will see. But I think that as many people before me say today, the openness of the solution and the community behind it, it's the driving factor. Just to make a different example and cite another talk of this morning, like 20 years ago, I was doing molecular dynamics and using GROMACS, and the reason that I chose GROMACS to do my PhD thesis, it was that he had a very rich mailing list. It was full of information, and I could learn a lot about how to run simulations. So the driving of the community is probably a critical factor in choosing a technology in this way, because you are dealing with humans, and science is the latest step of the pipeline, even if it is the most important one. One of the aspects in which we work a lot and we try to do interesting things is monitoring and data analytics for HPC. Because an HPC cluster is meant to crunch numbers as a final purpose, but it also produces a lot of numbers as a lot of data. And the environment around it also provides a lot of data that has to be integrated and understood and clean and managed if you want to have a a system that is energy aware on which you can build policies that optimizes use. And this is now, I mean, it has ever been important, but it is even more important today, and its relevance it will grow probably, given the condition of the world, I would say. And so we developed with Cinega and University of Bologna a project that is completely open source. You can find it on GitHub, open issues contribute to it. That is basically a data lakehouse for HPC. So it can ingest data from basically every kind of source, or can sit aside other silos like I don't know, Prometheus or other time series database. Allows you to unify all this data and access it with SQL queries. So you have a unified model for it, and it exposes it with tools from dashboards to machine learning and MLOps tools or notebooks, so that you can really not only look at the moment right now, but elaborate policies, train anomaly detection models, and really make your system more efficient. And this is important because, of course, in this way you can integrate a lot of data. For instance, we have a case in which we were able to integrate data from the grid provider into the cluster, validated with the internal consumption, take data from other sources, and evaluate the carbon footprint rather than just the watts and the joules that we are consuming. And this allows you to drive your policies to more sophisticated metrics rather than just energy. And then, of course, since you have the machines and you have the models and you have the tools, you can think of using models and AI agents to drive your monitoring infrastructure, and actually let the agent do some of the actions if you are that brave. And why this is important? It is not only the energy, as I said, there is a growing amount of literature in the HPC community that says that data centers are an environmental thing to be considered. There can be a pushback from the community, so the ability to understand how it is, what is the impact of the data center, how to create smart metrics is very important. And of course, this is even more important with the disruption, the Ramageddon that we are experiencing, that is hitting very hard both vendors and system integrators like us. Of course, to deploy models, to train them, train maybe not, but let's say at least fine-tune, and having different models for different purposes, and at the end of the day, deploy agents to help you in the predictive maintenance, let's say, of a cluster, you need an environment to do that. And in this, we follow the same approach of Hexamon, so that is create an open source stack in which we provide the necessary glue, have a stack that is opinionated, so from the many different choices that you have in the world, you have something that is as lean as possible and consistent, that can be deployed with a simple tool like Ansible playbooks, and is running after that. And in this case, while Hexamon is meant for monitoring and analytics, Urania is developed for model, I would say model life cycle. So from the moment that you prepare the data to the moment in which you start giving tokens to people and making inference, and of course you have to monitor the model. And of course they share a lot of common components. And on the fact that they share a lot of components and purposes, and the experience that we have working with Hexamon and Urania, we decided to somehow rearrange the products and have this thing that call it Phoebe. Phoebe, if you don't know, is the tidiness of light. So it's the, I think, the grandmother of Helios. And we created this, we are creating actually, still in MVP status, an opinionated stack to completely govern any kind of data that you want to have in your system, from the ingestion phase, the cleanup phase, the status that you will give to this kind of data, and who can access it, because this is one of the most critical part of our workflow, and this was also stated before in the, by Maurizio and Roberto, and it's very, very critical. And well, what about using these tools actually to provide some numbers and understand what we can use and how we can use them? So we have access to a tiny portion, not a complete system, of these GB200 and VL72 systems, and we used it to deploy our stack and run a few benchmarks on open weight models, basically. And since we had only access to a part of it, of course, we focused on inference. And the idea was, if we are going to deploy some of these models internally for fine-tuning, because we cannot use all the tokens of a general provider, what is the best model, and what is the best model, say, energy-aware, basing on the reason that I was giving you before. And so we run a lot of other tests that I'm not showing for reason of time, but this is the message. So we were keen to measure the token per watt per second of different models under different conditions, and both to provide the general knowledge that is usually not so easily available, and also to drive our choices and to understand what to use internally for our purposes. It, of course, is, I mean, most of the HPC numbers are created now and crunched now by GPUs, but it's not only GPUs. And I want to give you a glimpse of alternative. This is once again work done by some of my colleagues that are present here. And we are looking at simulations from astrophysics applications. So I assume that they were some kind of multi-body simulations. And we are comparing x86 CPUs runs with the same kind of run executed on a single RISC-V based accelerators. And the interesting thing is that the RISC-V accelerator is better both time to solution wise and energy to solution wise. RISC-V is an open ISA, and it has a lot of promise. We will see if how many of these promises will see the light, but this I would say something really impressive, that you can run actual workloads on this kind of machines. The last point that I want to touch is, so we have heard before about OpenChami. I tried to explain briefly why we use OpenStack instead of some more traditional way to deploy HPC clusters, and the reasons are very much the same in many cases. And in all these solutions, we are trying to cope to things that doesn't get along very well. So performance and flexibility, and there is always a trade-off. And in any cloud-like solution that you use for HPC, you are giving flexibility, adding a layer of abstractions to the stack, basically. So you have Kubernetes and maybe virtual machines, whatever. One alternative would be to build these systems on the fly directly from the hardware. So use disaggregated systems. This is very interesting. I don't have numbers that I can show right now, but they are very promising. And it allows you to basically define physical nodes on the fly. And you can integrate these components in your software environment. And for instance, teach to Slurm or to Kubernetes may be a little more complicated how to create nodes on the fly. The point is that in this case, you are more efficient probably, and in this time of market disruption, it can be a very interesting proposition. But of course, you are adding one step of dependency in your supply chain, so it has to be understood. I'm done, so these are the three, not take-home message, I would say, three open questions that I conclude my talk with. And thank you again for having me.
Thank you, Giordano and E4. Any questions?
Thank you for the talk. Just a question on the RISC-V platform. Can you expand a little bit on it? How do you see the evolution of RISC-V? We know it's very expensive right now. It's also, to me at least, quite unclear how this is going to evolve at the European level. So just a few words from you.
This is a very hard question, and it depends very much on the amount of commitment that at least in Europe, the higher institution will take. So how much they will be wanting to wait for the technology to mature. The fact that from non-European entities you have already working hardware says that it can be competitive. And also the fact that some months ago NVIDIA released support for CUDA in it tells you that it's possible, but I don't know, it's very hard to forecast when it will be performance and economically competitive with the other architectures. Maybe I wouldn't tell and just make my bet in the stock market, I don't know.
We have another question over here.
Hi. You mentioned photonic fabrics in your talk.
Yeah.
Or on the last slide. Or also, what about photonics computing? I mean, processors built on photonic technology. I know of a company, basically it's from Germany. Their name is Quant.
Yeah,
It has nothing to do with quantum computing, but they do photonics processors. And they also have some products in the pipeline. For example, an installation at LRZ. What do you think about photonics computing?
So here I said that for the networking part, and for that it is basically still too expensive to be really an advantage, but it may be optimized to be competitive. And then too expensive depends on not only on the technology, but also the fact that other pieces of the supply chain can be more or less up in price, as we are seeing. Concerning the photonic computing, I know we are in touch with this company. We are talking with them, and it's a very interesting proposition, but I don't think now that is as mature as the other examples that I did.
I mean, it also looks very promising in terms of energy efficiency.
Yes, it's very promising in terms of energy efficiency. And I mean, this also is a perspective not only based on technology, but on the wide community. Maybe Europe and Switzerland as a whole geographical area are more interested in energy than other geographical areas because it's more, the supply chain of energy in Europe is much more brittle. So it could drive the adoption, even if it is less powerful overall.
Okay. Thank you.
Thank you, Giordano.
Yamale, yo,